Chemistry is the study of matter. A chemist is someone who studies matter, and matter is anything that has weight and takes up space. Everything that you see in the world is made up of matter. There's 3 states of matter. Solids have a definite shape and a definite volume. Liquids, the shape can change, but it has a definite volume. And in gases, there's no definite shape or volume. They can take the shape of the container they're in. And we talked about liquids being poured from one container to another, that it would have the same volume but possibly a different shape. And we talked about how gases like perfume or smells can start in one area of the room and spread out. Molecules are tiny bits of matter, and in solids they're tightly packed together and they vibrate in place. In liquids, they slide past each other and change position. We talked about how that was helpful when you are swimming because you can slide around in the water. And in gases, they're farther apart and they move freely and can easily spread to all parts of the container. This was an animation about how a solid could move and how things vibrate in place. This was an animation of a liquid where they're freely flowing past each other. And then this animation was for gas and how it spreads out and takes the shape of the container that it's in. How can matter change from one state to another? Freezing is going from a liquid to a solid, melting from a solid to a liquid, and evaporation from a liquid to a gas. Condensation is changing from a gas into a liquid, and we use the example of being in the shower and the mirror fogging up, or possibly having a cold drink and bringing it outside into a warm environment, and the outside of the glass having water condensed on the outside of it, and that water did not come from the inside of the glass, it came from the moisture in the air around the glass. We also talked about sublimation, going from a solid to a gas, and our example for that was dry ice, where it's a solid block and then it goes straight to a gas. Metals and nonmetals, we talked about some properties of metals. Luster was the shininess, and that was a metallic shiny. Malleability was being able to hammer it into shapes like a paper clip or tinfoil. Then we watched a series of 3 videos on metals, nonmetals, and metalloids, and those clips are summed up in these in this table where the state can be solid in metals except for mercury. In nonmetals, you have solids, liquids, and gases. The luster for metals is bright and shiny. For nonmetals, it's dull. For color, you have silver gray except for gold and copper in metals, and you have different colors in nonmetals. Metals are good conductors of electricity and heat, and nonmetals are poor conductors of electricity and heat. On the periodic table, metals are on the left side of the heavy black line and nonmetals are on the right side. And the one difference was hydrogen, because hydrogen is a little bit different and it has some unique properties. So even though it is on the left side of the heavy black line, it is a nonmetal. Metalloids are these elements that are here along the black line, and they have properties of metals and nonmetals. On the second day, we learned watched an element song. We talked about how elements are substances that can't be broken down, and that the periodic table has chemical symbols, and this shorthand for writing the names of the elements are the same all over the world. So the symbol H for hydrogen is the same symbol in China, the same symbol in France, the same symbol in Canada, that even if the language is English, or no matter what the language is, the symbol H is the same. Then we talked about some rules for writing chemical symbols. The symbol is usually only 1 or 2 letters, and if the symbol is 1 letter, the letter is a capital. If the symbol is 2 letters, the first letter is a capital and the second is lowercase. Just like you would write your name, the first letter of your name would be a capital. Examples were aluminum, hydrogen, calcium, and lead. We also talked about how even though lead is spelled L-E-A-D, that the symbol is capital P, lowercase b, and that is because the alphabet that was used to establish the symbols was the Latin alphabet. And the reason that we have so many similar symbols is because our alphabet is derived from Latin. Then we talked about atomic number and how it's like a jersey number in sports. It gives you the identity of the atom. And then just for fun, we went through and did some famous sports jersey numbers. Hydrogen is number 1 and carbon is number 6, and that tells you something about their properties. So just for fun, we looked through these famous jerseys. Deion Sanders is 21, Derek Jeter is 2, Jerry Rice is 80, Jackie Robinson's 42, John Elway is 7, Magic Johnson's 32, Wayne Gretzky was 99, and Babe Ruth was number 3. We watched a clip from Sandlot talking about Babe Ruth. Lawrence Taylor is 56, and of course Michael Jordan is 23. We watched a clip on different elements burning different colors, and we talked about how the periodic table arranges elements by weight, which is the atomic mass, the number on the bottom of the tile that tells you which element you're looking at. And Dmitri Mendeleev was the one who created the chart in the 1800s, which became the first periodic table. There have been lots of scientists that worked on it, but he gets credit for starting. The atomic weight is the total number of protons and neutrons in the nucleus of an atom. We looked at the periodic table as these tiles and talked about how the top number is the atomic number. Then you have the symbol, the name, and the atomic weight or mass number. To find the number of neutrons in an element, you subtract the atomic number from the atomic weight, and that gives you the number of neutrons. Because remember, the atomic number is the same as the number of protons. For carbon, atomic mass of 12 minus 6 for the atomic number gives you 6 neutrons. In that case, the neutrons, protons, and electrons were all the same number, but that's not always true. Like for potassium, you have 39 as the atomic mass, 19 is the atomic number, and you have 20 neutrons. Atoms are the smallest part of an element. They're very, very small. They don't change in a chemical reaction. Atoms are made up of subatomic particles. Protons are positive, electrons are negative, and neutrons have no charge at all. Substances with opposite charges attract. Same charges repel. Atoms are neutral. They have no positive or negative charge. The number of protons is equal to the number of electrons in a neutral atom. And the nucleus contains the protons and the neutrons, and the electrons move around the nucleus in an electron cloud. Then we talked about ions, which are charged particles. They have more electrons than protons, then they're a negative charge. If they have more protons than electrons, they're a positive charge. And we used the little saying, keep your eye on those electrons, so that you knew that it was electrons we were changing to make a charged particle, because if you change the number of protons, then you're changing the element itself. We talked about a compound being a combination of elements that has different properties from the element that forms it. Unlike living beings who are a product of both parents and have some of the traits of each parent, a compound is completely different than the elements that form it. We have formulas to write the names of a compound and subscripts that tell you how much of each element is in the compound. And then we gave some examples, like water is H2O, 2 hydrogens, 1 oxygen. Sodium is NaCl. Carbon dioxide is CO2. And sugar is C6H12O6. Baking soda is NaHCO3. Mixtures are different substances mixed together, but they're not chemically combined, and they can be separated by a physical process. We talked about Chex Mix being a mixture. Seawater is a mixture because you can evaporate the water. Soil, you can separate different parts of the soil through different methods. And air, we talked about air filters and how we filter the air in our homes. A solution is a special type of mixture with 2 or more substances that mix evenly with each other on a molecular level. And an example was a soft drink. Tap water, we talked about how tap water includes chlorine and fluorine. And then we did a little review about physical and chemical changes, that a physical change changes the shape or the size of the material, but the substance itself does not change. And examples were breaking a wooden stick, tearing a piece of paper, or stretching a rubber band. Chemical change is when a new substance is formed. For example, burning a piece of paper. An iron nail rusts, baking a cake. And we talked about how after you mix all the ingredients for a cake and put it in the oven, that you can't then just separate the eggs out after the cake has baked because a chemical reaction took place. We had a funny story about the Addams family. Positive Patty proton and nerdy Nelda neutron could stay in the arcade, the nucleus arcade. So they are the 2 particles that stay in the nucleus, and then a enraged Elliott electron flew around the outside and wasn't allowed in the neutron, in the nucleus, but at the same time he was attracted to positive Patty. And then there was a silly song, and then you guys did an Addams Family math challenge where you found the number of neutrons in each element. Just remember that the atomic number is protons or electrons. The mass equals protons plus neutrons. And then these are just some examples for oxygen. Then zinc. And lithium.